Good morning to one and all. My name is R. Narendra Kumar, working in the Department of Mechanical Engineering as Assistant Professor in the Institute of Technology and Engineering. Okay, now I would like to give a demo on the engineering graphics subject on the topic of conic section. Okay, now what do you mean by conic section? A conic section curve obtained by cutting a right circular cone in the plane direction relative to the axis n. Okay, now in the conic section we are having three categories. One is ellipse, other one is parabola, other one is hyperbola. Now what do you mean by ellipse? Okay, now definition of the ellipse. Okay, when the plane is inclined to the axis and cut all the generators of the cone, then it is called an ellipse. Okay, ellipse categories we are having different categories of ellipse. One is concentric circle method, other one is rectangle method, other one is oblong method, other one is arcs of circles method, other one is rhombus method, other one is general method. This is the general method which is we are having in the syllabus. Okay, next coming to the parabola we are having rectangle method of tangents, abscissa method. Similarly hyperbola same, rectangle method of tangents mean rectangular method or oblong method. Next basis locus method, which is nothing but directrix method. Now see that in the conic section we are having ellipse sectional plane. This is the cone which is cut by all the generators and which is passing through the axis is nothing but an ellipse. Now in the parabola it is the cut section is inclined to the axis and passes through one of the generators then it is known as parabola. And hyperbola, it is parallel to the axis and cut only one generator, then it is known as hyperbola. Now what is meant by common definition of an ellipse, parabola and hyperbola? It is a locus of a point moving in a plane in such a way that the sum of its distance from the two fixed points remains constant, which is known as eccentricity. Okay, and the sum of equal to the length and major axis to be fixed to points focus F1 and F2. Now in the ellipse we are having E less than 1. E is nothing but eccentricity. Eccentricity definition is the ratio of distance from the fixed point to the fixed directrix is known as eccentricity. Now in the ellipse it is the condition E less than 1 and parabola E is equal to 1 and hyperbola E greater than 1. Let us see one problem which is having draw ellipse by concentric circles method. Take the major axis 100 mm and the minor axis as 70 mm. By concentric circles method, ellipse major axis is 100 mm and minor axis is 70 mm. Also draw a tangent and a normal to the curve. Now see that in the question it is given as the major axis as 100 mm and the minor axis as 70 mm. So we need to draw first of all major axis as 100 mm, and minor axis as 70 mm. So in order to draw that major axis and minor axis, I am going to draw one centroidal axis which is both are perpendicular to each other. Okay, now say take a circle radius of 50 mm of major axis. Take a circle of radius 50 mm and draw one circle. Take a circle of 50 mm radius and draw one circle. Similarly, take 70 mm radius, means 70 mm diameter, which is given as radius of 35 mm. Now smaller circle of radius 35 mm. Draw another circle. Now these two circles having a common center which is nothing but this is the centroidal point. Now divide the circle into n number of parts. Divide these two circles into n number of parts, means that is 360 divided by n, which is equal to 360 divided by, I'm going to take as 12 parts, so each angle is 30 degrees. So placing the set square in this direction and dividing the circle into 12 parts. Now this is the first angle 30 degrees, next this is the 60 degrees, next 90 degrees, next 120 degrees, next 150 degree. Now I'm going to give this one point as first point, and this is the second point, third point, fourth point, this is the fifth point, sixth point, seventh point, eighth point, ninth point, 10, 11, 12. And this is the first point of the inner circle, this is the second point of inner circle, third point of inner circle, fourth point, fifth point, sixth point, this is the seventh point, eighth point, ninth point, 10th point, 11th point, and 12th point. Now this is the starting point of the circle, this is the point of P1. Now we need to draw, you need to place the scale to the axis and need to draw one horizontal line from the point 2 and the vertical line from the point 2. Or let us consider the small circles as dash points, and this is the 1 dash point, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, 12 dash. Now need to draw from 2 dash horizontal line and from 2 vertical line. Similarly from 3 dash on horizontal line and from the 3.1 vertical line. These two lines will be meeting one particular point. Similarly in the fourth point, similarly need to draw from the fifth point one horizontal line and from the 5 point as a vertical line. Similarly from the 6 dash on horizontal line, from 6 as a vertical line. Similarly from 8 dash one horizontal line, similarly 8 point as a vertical line. Similarly 9 dash as a horizontal line, from the 9th point as a vertical line. Similarly 10th point, similarly 11th dash as a horizontal line and 11 as a vertical line, 12 as vertical line and 12 dash as a horizontal line. Now these 2 points will be meeting at one particular point. This is the point P1, P2. Now this is the point P3, this is the point P4, this is the point P5, this is the point P6, this is the point P7, next point this is the point P8. Now this is the point P9, this is the point P10, this is the point P11, and this is the point P12. This is the point of P11. Now join these points with the help of these points. You join one curve, then the curve traced by the points is known as ellipse. All the points from the P1 point, P2 point, P3, P4, P5, P6, P7, P8, P9, P10, P11, P12. If we join all these points, then the points traced by the then the curve traced by the points is known as an ellipse. Now the major axis, it is given as of diameter 100 mm, of diameter 100 mm, and the minor axis it is given as of diameter 50 mm, 70 mm, sorry, of diameter 70 mm. Now for this ellipse we need to draw a tangent and normal at any point on the curve. In order to draw the tangent and normal at any point on the curve, we need to find out the focus F1 and F2 where it was located. In order to draw that focus F1 and F2, we need to find out the focus F1. Means focus F1 is nothing but the focus F1 and F2 are the focus. We need to find out the focus. Now in order to find out the focus F1 and F2, now we have to take this center. I was going to take this as an O. Now O to 4 dash as a distance. In order to find out the focus F1 and F2, O to P1 as a distance, O to P1 or 1 point as distance, O2 1 point as a distance, and center as 4 dash as center. Draw an arc on the left side and right side of the circles on both directions. You will get the F1 and F2 points. Now let us consider one point which is located on this ellipse. Now I'm going to consider this as an ellipse, one point which is located at one point which is located at a distance. So this point we need to draw one line from the focus F1 and other line from the focus F2. Join these two lines, these two will be perpendicular to each other. Okay, now taking for F1 or F2 as more than distance, this point is treated as S. Now for F1 and F2 more than distance, you need to bisect arcs. We need to bisect an arc from F1 to S distance. You need to bisect one arc more than half, and F1 or F2 as center, another arc. These two arcs will be intersecting one particular point. That point is nothing but R. From that point you need to draw one line. This point is S. From that point we need to draw one line. This line is passing through the previous cut section points of arc. Okay, now from to this is called normal line, and to this normal, if you place the search square in 90 degrees, now this is called tangent line, tangent TT.